Okay, class, so let's move to the part 3. That is what we call phases. So in the previous part 1 and part 2, you learned about sinusoids. So you did by Vm sine omega t plus phi, right? The phase. And then you're going to transform here to what we call phasors. So what is actually phasors? We need phasors to solve the circuits. This is called RLC circuits. Okay, so sinusoids are easily expressed in terms of phasors. So it is a complex number. So I believe you have learned complex number in your maths, right? So when you're talking about complex number, it has what we call the amplitude R and also the phase that is called theta, okay, or phi, and it written in the bold phase. So in order for you to understand these phases, you need to be familiarized with complex number. So let's recall back what is actually complex number. So complex number, you have what we call real and what we call imaginary. Okay, so the real part here is what we call x, and the imaginary part here is what we call y. So this is one form of a complex number. This is what we call rectangular form, where the z is actually x plus jy. Okay, so what is j here? J here is the imaginary. So j is actually equal to minus 1 square root, or if you make it squared together, so it becomes j squared is equal to minus 1. Okay, so another important concept is j multiplied by j. Here j squared is minus 1, right? So j multiplied by j is minus 1, the imaginary, or you have the division like this. So 1 over j is actually minus j. So these two are the important concept for the complex number when you are trying to solve the phasor equation after this. Okay, so one we call rectangular form, another one we call what we call polar form. So again, z is a rectangular form, x plus jy. Another form what we call polar form is r, the angle is phi. Okay, how you relate r and here? So let's see the next video slide. Okay, this is what I say here just now. The y-axis is the imaginary and here is the real. Okay, so if we say z equal x plus jy, what does that mean? Here is x, the real part is x, the imaginary part is y, the height here is y. Okay, so if we want to change this one to the polar form, what is r equal phi? What is actually r? So r is actually the height, the what we call theorem Pythagoras, right? Theorem Pythagoras. So this is the r. So how you can get the length of the r is equal, use the theorem Pythagoras. So this is y, x squared plus y squared. Okay, and how you can get the theta here? Theta here is a tangent inverse. Tangent is opposite side, right? So y over x. So this is how you transform rectangular to polar. So we have another one here is exponential, that is r e j phi. Okay, so usually what we will learn here is only rectangular and polar. So how you're going to change from the rectangular to polar? This is that I already mentioned just now. How you change polar to rectangular then? So you are given z equal r with phase. You need to change to the rectangular plus jy. So what is x actually? So if you redraw again, this is a real, this is the imaginary, right? You are given theta. So you know this one is x and this one is y. So how you can get x and y? Okay, if you see sine theta, sine is SOH, right? SOH, opposite hypotenuse. So y over, let's say this is r. So you got y equal r sine theta. So if we make it cos theta, cos is kah, right? Kah is a side hypotenuse x over r. So you can get x is equal r cos theta. So this is what you are going to, how you can relate this one. S equal r cos theta, y equal r sin theta. Hence, this is a rectangular form, this is a polar form. So what is actually r cos theta plus j, the imaginary is j sin theta. Okay. So let's see one example. So the first example, so identify first. A is actually rectangular form. You need to change to the polar. So z equal 5 plus j2. So first what you need to find the r. So r is the Pythagoras, right? 5 squared plus 2 squared. Okay, and then you need to find the theta, right? So theta is tangent inverse y over x. So what is actually y? This is, if you make it here, this is 5x, right? And here is the imaginary, this is 2, so this is y. So y over x is 2 over, so this is tangent inverse 2 over 5. So let's calculate. Tangent inverse 2 over 5 is 21.8 degree. So what is z in the polar form is 5.38. The angle is 21.8 degree. So that is part A, rectangular to polar. How you change your polar to rectangular. So you are given tan angle 30. Okay. Okay, so this one, so x equal r cos theta, right? So we here tan cos 30, y is equal to tan sin 30. So let's calculate. Cos 30 times 10. So here 8.66. Sin 30 times 10 is 5. Okay, so what is z? Z is equal x plus jy, that is 8.66 plus j5. Okay, so that's how you change from rectangular to polar and polar to rectangular.